Welcome to Brain Vision.
In this example, we're going to determine what the ratio of the final pressure to the initial pressure is when we know what the initial and final temperatures of an ideal gas are. And also, we're assuming that the volume of this ideal gas is constant during this whole change, which is very important. So we're going to star that. Okay, so if we hear ideal gas, we should think of the ideal gas law, which is PV equals N times R times T. All right, so if the volume of our gas is constant, notice if we solved for volume here by dividing both sides by P, if our volume is constant, that means that this whole right side of this equation is also constant, right? So what that means is that at any one point in time, we can equate this value to any other point in time for different temperatures and pressures. So that means that NR times a T at one moment times a P at that same moment is going to be equal to NR times T at some other moment over P at some other moment. Or this leaves us with T1 over P1 is equal to T2 over P2. Or since we're looking for the ratio of P final to P initial, or P2 to P1, we can solve for that. So if we cross multiply that equation, we'll have P2 over P1 equals T2 over T1. So for this setup, all we need is the initial and final temperatures to solve for this ratio here. So for this first one, we have 70 for the final temperature and 35 for the initial temperature. So if we plug those in, we'll have 70 over 35 Kelvin, which is just 2. So the ratio of the final pressure to the initial pressure for this first one is just 2. Now let's look at a slightly different scenario where our initial temperature is 35 degrees Celsius and our final temperature is 70 degrees Celsius. So first we're going to want to convert these to Kelvin. So remember, to get Kelvin, we're going to add 273.15 to our Celsius number here. So these in Kelvin would be 308.15 Kelvin. And over here we'd have 343.15 Kelvin. And what we can see is that this change here is actually a much smaller change in Kelvin, right? We only went up about 40 degrees Kelvin, whereas in the previous example, we went up about 40 degrees in both, but we're going to see that overall this ratio is going to be much smaller. So if we do the exact same thing as before, say that the ratio of P2 to P1 is the same as T2 to T1, which is the same as 343.15 Kelvin over 308.15 Kelvin, we're going to get a value of 1.11. All right, so what did we just show? We showed that if we know we're dealing with a constant volume process for an ideal gas, that the initial and final pressures are related to the initial and final temperatures just by this equation here. P2 over P1 is equal to T2 over T1. So if we have T2 and T1, we can solve for the ratio of the pressures.